Good afternoon, class. In today's video, what I wanted to do is talk about relativistic momentum. So normally, and I hope you remember that momentum, as we saw in the earlier part of the course, was P equals mv. But now that we're adding relativistic considerations into the mix, now we have to change things. So in in a previous video, I did a relativistic mass, and in that I talked about how mass changes at the faster that you move. In a non-inertial reference frame, as you're moving faster, you will actually your mass will start to increase. So given that, we have to now take the next step and actually figure out what happens with momentum, because that's actually going to be important, especially as we get into this journey towards E equals mc squared. We'll get there. We'll get there. So we do that, we need to remember, I'm just going to rewrite this because this will help build the groundwork for when I actually derive E equals mc squared for everyone. But we're going to, instead of it going to be V, it's going to be U. I'm going to declare that mostly because we're dealing with Lorentz transformations, so it's kind of just easier to kind of clean up the language a little bit, to just say, okay, instead of V's and U's being thrown around everywhere, we're going to call the speed or these velocities in S prime, they're going to be just U. Okay. However, we got to take into account the fact that there is a relativistic mass here. So when we rewrite this, so as we write P prime or momentum prime, it's going to be, the velocity is the velocity. That will be measured no matter what. But the mass does get measured differently based on which frame of reference it's in. So we need to take that into account. So when we do that, we recall that mass, or the mass, relativistic mass, is going to be gamma times the actual mass of the object when it's at rest. So now we've got our new definition of momentum, at least in relativistic terms, which would be mu over the square root of 1 minus u squared over c squared. Now, you might ask me, why didn't you just leave it as gamma mu? That would have made more sense. And you're right, it would have. It's just that I wanted to show this and this, because this form and this form, because when you go on the internet, when you start looking up what the relativistic momentum equation is, you'll actually see this one a whole lot more often than this one, even though I could have stopped here, but this one's more commonly seen. So I thought I'd just show that both of those, just in case, so that it makes it easier to see what's going on in the math, especially when we get into the next one. So when I start to derive, just as a preview, that when we start doing E equals mc squared, that will be an advanced video. These have all been more on the intermediate levels. So we'll be working on that. Eventually we'll get to E equals mc squared, and it should be fun. So that concludes relativistic momentum. Good luck in your studies. May the force be with you.